In our previous lessons, we've been working on graphing quadratic equations or quadratic functions in factored form and vertex form, and we're going to do a review of each type again today to prepare you for your upcoming assessment. So we're going to focus on a couple of problems together, and we will go from there. So if we look at our first one, we can see that our equation is here. Y equals 2 times the quantity x plus 2 times the quantity x minus 2. Again, we always start off by saying to ourselves, what form is the equation written in? Because it will tell us how to begin our graph. This equation here is written in factored form, right? And so based on what we see here, we can tell a couple things about it already. Because it's in factored form, we can get the x-intercepts to get our graph going. Then we could figure out where the x is symmetry, our vertex, and build around it in our table. We also see this 2 as like the greatest common factor, your a value, which is telling me that it's 2 times faster than it was previously. So I should anticipate my graph being more narrow than what our normal function x squared looks like. So in terms of the x-intercepts, we set each of those factors equal to 0, either on our paper or in our heads, and find out that our x-intercepts are located at -2, 0, and 2, 0. So I can establish my graph and plot those points. Now, because they're mirror images of each other, the mirror has to be halfway between them. So from -2 to 2 on our x-axis, that is 4 spaces, so half of that would be 2, which means my axis symmetry would be here at x equals 0. Now, the vertex lies on the x symmetry, so I know that the x value for the vertex is also 0. To find its corresponding y value, I'm going to take that 0 and put it into my function and work it out to see what that's going to be. So I know 0 plus 2 is 2, 0 minus 2 is -2. -2 times 2 is 4, which is negative, times 2 again, that would have to be a -8. So I have the y value for my vertex at -8. I also can plot that right here for my graph. Now, a couple other things. If this is the vertex and these are the x-intercepts, we can see that it's concave up. We also know because the a value is positive, that also should be concave up. So the next thing I want to do in my table is establish some values to the left and right of 0 to see what's going on, also to the left and right of my x-intercepts. So I might want to look and see what's happening at -1. I already know what's happening at -2, maybe -3. See what's happening at 1. I know what's happening at 2. Maybe let's see what's happening at 3. And just like I did for the vertex, I take each of these new input values, put them into my function to see what I get out. And again, because this is a mirror, right, the axis symmetry goes through the vertex, I should see mirror images in my table, my output column. So again, whatever inputs I wanted to test, I'm putting them into my pattern and then just working it out. You could type it exactly how it is into your calculator and hit enter, or you can do it piece by piece in your head like we did with the previous one for the vertex. That's totally up to you. So regardless of which ones you're picking and you do your calculations, we should have the following outputs. If I use a -3, I got out a 10, which matches with our +3's output because they're mirror images in our table and our parabola. If I use the -1 as my input, I get out -6, which matches for the input of 1 as well, because they're mirror images based on my parabola. So if I plot these additional data points, I can see the nice shape of my concave up parabola. And remember, we connect all the data points because it's a continuous function. And then we can answer any other remaining key features. For example, our y-intercept, we're looking for where it crosses the y-axis, and we can see that's right here, which happens to be our vertex at 0, -8. Our domain, we know, never changes for your parabolas from -infinity to +infinity. That's saying all real numbers can be used. The range, again, from lowest to highest, because it's concave up, the lowest output we can have here is the y value for the vertex, -8, and that will continue to +infinity. And again, we already mentioned that it's concave up, because the a value here was positive, and we can also see that confirmed when we started plotting the points for our graph. Again, when it's in factored form, we can find the x-intercepts, then find the axis symmetry would be in the middle of those, and along that axis of symmetry, you have the vertex. We started building our table with the vertex in the center. We've got the x-intercepts spaced out on either side, and then we picked other data values to the left and right of the vertex to fill in our parabola. And all we're doing is a quick substitution for whatever x values we use into our pattern to see their corresponding y values. Now, the other one that we're looking at is here. And again, you want to say, well, what format is this written in? And this is the vertex transformation format, because we can see we've got the quantity squared. So we're thinking about the movements, right, and get that vertex axis symmetry going first, and then the other points will come along the way. So if we think about the transformations here, I see this negative in front, so that tells me that it's reflected over the x-axis, and this should be concave down. Here, this x minus 7 is telling me that the graph is being shifted to the right 7 units. And this plus 1 is telling me that the graph is being moved up 1 unit. Well, if I'm going to the right 7 and up 1, that's where my vertex is going to be. And I also know that the axis symmetry is going to have to go through the vertex, so it has to be at x equals 7. So right now I have those three things going for me: the concavity down, the vertex being at 7, 1, and the axis symmetry being at x equals 7. Remember, the axis symmetry is always written as an equation. Now, I've got to build around my table, picking x's to the left of 7 and to the right of 7. So left of 7 would be like 6, 5, 4, anything this direction. To the right of 7, 8, 9, 10. And you're selecting what values you want to choose to test. And so all I'm going to do is take the input values, put them into my function, and see what I get out. So if I wanted to start with the 5, I would put that in. You could type this in exactly how you see it in your calculator, or simplify it piece by piece to see what you get out. And I would do the same thing for 6. I could do the same thing for 8. I could do the same thing for 9. But remember, because this is the vertex 7, 1, whatever I see from the left of it for the outputs, I should see on the right of it for that symmetry. So within doing the calculations, the output should be -3, 0, 0, -3. So I see the symmetry again with the outputs by doing those substitutions. All I have to do is plot my data points. Again, we can see the concavity is down, connected to make our continuous function for that parabola. Now, in terms of key features, x-intercepts where it touches or crosses the x-axis. We can see that happening 2 places here on the graph. We also can see it in our table because the outputs are 0. So my x-intercepts are happening at 6, 0 and 8, 0. Now, in terms of the y-intercept, that's where it's going to touch across the y-axis. And I know because it's decreasing, it's going to do it someplace down here. So what I'm going to do is, when it's a y-intercept, the x value is 0. I'm going to do a quick substitution of 0 into my function to see what I get out. And that would be my y-intercept. So if I'm putting my 0 in, that would be -7 squared, which would be 49. Take the opposite of that, -49, add 1. That would have to be a -48. Domain, we know, does not change. It's always -infinity to +infinity. And our range from lowest to highest, now it's concave down, so it's going to keep decreasing, so there's not really going to be a lowest. So we're going to have to start with a -infinity with our parenthesis, and the highest it can go is our output here of 1, which happens to be at our vertex, and so I need a bracket for that. So again, when it's in that vertex transformation format, How do you start? You think about each of the transformations and you plot your vertex, you plot your axis symmetry. You then pick values to the left of that vertex axis symmetry and to the right, substitute them into your pattern to get their outputs. Plot them to create your graph, and then you can answer your key features. These are the types of things that are going to be on your assessment coming up this week. Along with what we were practicing previously, if I give you the graph, could you come up with equations to match it? So things like this for your practice for today. So the remaining time is yours to practice and then to prepare for your assessment.